Hello. That's loud. So, a quick talk. Let me see. Oh, this one's not moving. Okay. Let me see this one's. Yeah. Sorry, technical difficulties. Let me see if I put this one over. I can. I can get something to work. That might do. Anyway, it's a bit rough, but bear with me. So HBase is a scalable distributed data store. It's modeled on Google's Big Table paper. We've implemented most of it, I suppose. We have different nomenclature. There's still some stuff to do, but roughly there. We grew up out of Apache Hadoop project. We were originally a contrib. Now a top-level Apache project. You'd use HBase when you want to add random read-write to your Hadoop stack. That's when you'd want it. Kind of a key value store sort of thing. We run on top of Hadoop's distributed file system, HDFS, and then we use things like Zookeeper for cluster coordination. Who uses it? Here's a few of the people that use it. All these people are interested in scale. That's why they're using HBase. Facebook, they've talked a lot about their HBase use. It's like used for like their metrics, their ODS system. They're the eyes and ears of what's going on at Facebook. It can't go down. Who else is in there? It runs on a Yahoo's grid. There's people like the Flurry people. They all your mobile apps, they all report home to a HBase cluster. That's the biggest that we know of, the biggest contiguous cluster that we know of. It's like north of 1,000 nodes. And then that cluster itself is replicating into 2 other data centers that are also of a similar size. But these people are all about scale. How is it used? I won't tease it out, I'll just dump it out on one slide. There's the data store as the dumping ground. All kinds of whether it's like a website, like say StumbleUpon, when they serve a page is made up of multiple features. Those features could be written by different engineers. The data set that they're pulling from can have different characters, but they have the one backing store behind it all. Yahoo's similar when they run HBase on the grid. They have all kinds of tenants doing all kinds of mad data scientist kind of things. And people like Salesforce. Salesforce will, give customers a table to do what they want with. Developers generally like this because they don't have to worry about scaling. Somebody else is doing it for them. They just get the tap on the shoulder from ops if they do something really stupid, such that they disturb the co-tenants. People like eBay, when you search for items in eBay, it's the data that goes into the search engine comes out of a HBase reconciliation store. There's like actually many databases that they pull from, and then they put it all into a single HBase cluster at the center of their indexing pipeline. They like it because there's a time dimension, so they can take a snapshot of the of what's for sale at any particular time. Then most people that run HBase, they'll also maybe use it as the backing store for their metrics. So things like OpenTSDB, the application that gives you nice graphs on what's happening in your clusters, your machines. You get your applications to write into the metric store. This is what Facebook's ODS is, and this is like the first production use case of HBase at Salesforce. This is what it's doing. They have their own metric system, so they can see what's going on across their many clusters. So HBase it plays in many positions. It's doing people are using it for all kinds of things, not all necessarily always appropriate. We're doing like OLAP and OLTP. If you try to do them both at the same time, we still have some work to do. So who runs the project? It's an Apache HBase Apache project, as I said earlier. But the main committer teams come out of these companies. Intel have quite they have a stake in the game now. They have 3 committers. Facebook have a big team to run their internals. Cloudera, where I work, we have 5 or 6 people, 7 maybe. Hortonworks, similar. The point I'm trying to make here is there's a bunch of people driving the HBase project forward. What's the current state? Our current stable offering is 0.94. We just made a release last week, 94.8. This release has settled down nicely. Release every month. Each one more stable, more performant. Some features. But the bulk of my talk will be about 96, what's coming this summer. The thing that we've been working on for the last year, our summer blockbuster. I have like 1,000 fixes or more so far. But let me talk about some of the main focus that has been behind the 96 release. We spent a lot of time on mean time to recovery. And what's this mean in the HBase context? So in the old cap triangle, HBase architecturally favors consistency over availability. So there'll be times when your data is offline, say when a server crashes, or maybe we're rebalancing, or stuff's being split. And so there's these phases during which, when the data is offline, there's these phases of recovery that we've been working on, trying to make the windows smaller, like detection, repair, notify. Each server runs a write-ahead log, and the write-ahead log of whatever's in memory. And before you can get the data back online, if you want to give a consistent view, you need to replay all those edits. The way it works at the moment is all the wall logs are farmed out over the cluster to be distributed in a distributed fashion. So, improving our MTTR there's been big strides made in '96. A lot of it's had to do with like HDFS fixes. If a data node hasn't checked in the last recently, then don't ask it to help you during the repair process. Just skip it. All these windows have been shrunk. Things like I talked about the distributed log splitting. Previous, we used to keep the data offline while that was going on, but now we actually bring the data online immediately, so you can start taking writes again, though you can't take reads. HBase comes out of, like I say, HBase came out of Hadoop. We use a lot of the basic Hadoop infrastructure in HBase. One thing we use in particular is the serialization format. You actually hand write how you want an object to be serialized and how you read it back in again. This was actually a problem when an object contained an object, another one contained an object, and they all were evolving at different rates. And then if you want to put that whole thing over the wire, do an RPC with it, that itself was versioned. It made it so we couldn't evolve. We couldn't evolve servers independent of clients, and we're trying to be an online serving system. We were bound up. We were looking for the freedom to evolve, so we moved everything over to protobufs. Everywhere we persist, we do in protobufs, whether in the system tables, file systems, up on Zookeeper, or when we put stuff over the wire. We also inherited Hadoop's RPC. And over the years, their RPC has accumulated an awful lot of cruft, uses things like Java proxy. There was a pluggable engine for whether you wanted security or not, or so you could choose different serializations. And we just got rid of all that, and we just moved to protobuf service. The whole thing is just cleaner. It's so clean now, we wrote a spec to describe it. But again, this is all about freedom to evolve. We have snapshotting in '96, table snapshotting. It's a good primitive for doing things like backups, replication, or offline processing. You go against the snapshot rather than maybe the HBase API. our equivalent of Leucine's Optimize. Has had a bunch of work done on it. It's pluggable. We have different implementations. That's probably my favorite thing is we have a whole suite of integration tests. We borrowed freely the Netflix Chaos Monkey. You can let it run loose in a cluster that's running either on a single node, or you can size it so that the same test is being run on n nodes. And you can ask it to run for like the weekend or for 5 minutes. But this has been really great at finding issues. Miscellaneous, smarter load balancing, revamped metrics, UI. It'll run on Hadoop 1, Hadoop 2. There's also been a load of fixes in HDFS. Go local, avoid the data node tax if the data is local. This notion of favored nodes, it's really important keeping data locality. This thing came from the lads at Facebook. When you write your replicas, you dictate where they're going to be so that if there's a crash, when you come up again, you come up on one of the favored nodes and your data remains local. I'll talk a bit about ecosystem, HBase ecosystem. There's stuff in HBase for, so hooking up your Python or your Ruby or nice UIs that are better than ours. But there's been a bunch of energy expended in one particular area, a bunch of ecosystem energy expended in one particular area. And the area that I like to call the chasm. This is me last weekend out for a ride. So this is my electricity bill. It actually comes out of every time I get a bill, my usage over time is shown. This has been provided to my power company by this O-Power, a user of HBase. So this stuff's coming out of a HBase cluster. So you have this nice little application over here, but then over on what you have on the right-hand side is is our dirty raw bytes API. That's all you have in HBase. So how do you write applications against it? How do you make it easy to write applications against this raw API? Friends of ours, Weeby Data, they've been experts in teaching people how to write big data applications. They've been doing it for a while. And they came up with this framework, the Kiji framework. It's the 80-20 rule. They made some choices. They're baking their experience teaching people how to do big data apps into this framework. So it's kind of basic, entity-centric, simple model. All the serialization is done with Avro. You can have all kinds of types, compound types. Each cell is versioned. And that's useful when, if you want to change versions, the framework takes care of it for you. And the same framework works whether you're going to the data via REST or over their MapReduce. They'll make sure that you have the same view all over. Open source and production deploys. I suppose people have been, jumping the chasm using SQL for a long time. Yesterday we heard Michael and Ted talking about Apache Drill, and Marcel was talking about Impala. This is a Chevy Impala. I couldn't find the logo for Impala. Sorry, Marcel. But the promise here is that you have a SQL query, and it doesn't matter what the data sources are. And these lads have been working on so that HBase can be a first-class data source. Closer in are the people at Salesforce. They've been writing this Phoenix. It's like this skin. HBase is a SQL skin over HBase. It exploits our triggers and store procedure facility, our coprocessors and custom filters. You just get the HBase via JDBC driver. So, SQI line or Squirrel, HBase shows up. It's nice. But a lot of energy has been expended in this area, making apps easier to run on HBase, or just write apps on HBase. What's coming next? It's about time we called it 1.0. It's been around for long enough. We kept getting beat up on this faster scan, so maybe like slower writes, better compacting, so that it comes read time, you can get more out of it. Some inspiration from columnar stores. Latency resilience, I think Jeff Dean calls it latency tolerance, but this, bring home the outliers. If there's a bad disk or you're running on EC2, it shouldn't be so extreme. In HBase world, what this means is if you're trying to read from one replica and it's not coming back fast enough, start up the second read against another replica. That's at read time. On write time, multiple wall writers. People who are spending time here. And related is just giving quality of service guarantees. It's hard in a HBase, given that we're running on HDFS, and then HDFS is it's the hardware and all those things. If you wanted to do real QoS guarantees, there's a lot that has to be hooked up. But we should be able to do something primitive so that if you're running that MapReduce job, against your HBase cluster, you can still do some aspect of low latency serving out the front end without it being affected. Something coarse in here. I was reading that design principles book, and we offend in many ways. HBase project does, but this one kind of jumped out. They talk about the flexibility usability trade-off. I think when fellas add features to HBase, they usually add a bunch of configuration as well, configuration that nobody really looks at. And just in general, I think that for the project, we want to move towards like ergonomics, like the JVM, just adapt to the workload ourselves internally. And just in general, be more forgiving. Just a general takeaway, we've been doing a load of work over the last year, and then 96 should be landing maybe July, end of August, or middle of August or so. Please keep an eye out for it. Just try it out. Thank you.